Question 1, I've labelled the parallel sides in red with the arrows on, and the line going across it from B to D, we can see there's an angle 76 on this side and down here on the other side, creating a sort of Z shape. Those are a pair of alternate angles, so they're going to be equal. So I've said here, angle BDE, so BDE, this one here in the middle, that is 76 as well because alternate angles are equal. Make sure you've given a full reason. Now, if that's 76, I've also spotted that I've got two sides here the same. I've got an isosceles triangle, BDE. So if I follow those two sides from here to the end, the two angles by that vertex here and here, they're going to be equal angles, because in an isosceles triangle, two sides are the same, but also two angles are equal as well. So if that's 76, that one there is also 76. Now finally, in a triangle, we know that the angles add up to 180. So I can take away these two from 180 to find this acute angle here, which is 28. But then to find x, I'm just taking 28 away from 180 again, because angles on a straight line add up to 180. So the shortcut of doing that is just saying that these two angles here, 152 in total, is going to be the same as that one, because I'm doing those take away from 180 to get that, and then take that from 180 to get back to this one. So the steps would be angles in a triangle add up to 180, and then angles on a straight line add to 180. Although, like I say, you'll see that the sum of these two ends up being the same as this obtuse one on the outside x. So make sure you've given a good few reasons there. The one I've not written down is angles in a triangle make 180, and angles on a straight line add up to 180. Question 2, it should look like this. Just to make sure how to do that, if I count the squares from this corner here to the reflection line, the mirror line, we're going 1, 2, 3, 4, 5, 6 squares along. Now I need to reflect it at 90 degrees. So if we turn our page this way, we can see that if I'm going 6 squares this way, I'm going 6 squares this way. Or we could sort of see I'm going across the squares, 1, 2, 3. So going across 1, 2, 3 to get to there as well. So you could turn your page that way and just go straight through the squares. But I think it's better to count the squares across and then reflect it up at an angle of 90 degrees. So I've done that with all 4 points, and it should be in the top left hand corner facing that direction. For number 3, I've written down the formula for the area of a trapezium. We add together the parallel sides, A and B. In this case, they are 4 and 8. We half that, and we times by the height, in this case 2. So 4 plus 8, half that, then times by 2. 4 and 8 is 12, half of 12 is 6, but then timesing by 2 again to get back to 12. So the answer for the trapezium bit is 12 centimetres squared. Square, nice and easy, it's just 4 by 4. 4 times 4 is 16 for the square. If we add those areas together, 12 for the trapezium, 16 for the square, we get 28 all together. Make sure we've learnt this, written down and learnt this trapezium formula for the area. We don't get given that on our exam, so we need to make sure that's in our memory. For number 4, likewise, area of a circle formula, pi r squared, pi times the radius squared. This is a half circle, a semicircle, so I've put pi r squared over 2. We've halved it. Always check, do we have our diameter or our radius given to us? We've got the distance all the way across, which is the diameter. So that means the radius must be half of 8, which is 4. So I'm going to put there r equals 4. So if the radius is 4, I must do pi times 4 squared and then half the answer. 16 times pi, half of that is 8 pi. Stick it in a calculator, 25.1. That's been rounded to 3 significant figures. Again, the mistake I've seen quite a lot is people forgetting to half it. Pi r squared would be a full circle. We've only got half of a circle, so make sure we half the answer. Number 5 is Pythagoras' theorem. the two shorter sides squared, x squared plus 24 squared. That gives us a total which is the same as the longest side, the hypotenuse, squared. So my equation is x squared plus 24 squared is the same thing as the longest side, 25 squared. I've worked out using my calculator what 24 and 25 squared are, so I've rewritten it. X squared plus 576 equals 625. That's just those numbers squared. Now to get x squared by itself, I have to do the inverse of plus 576. I've taken away 576 from both sides. That leaves me with x squared by itself equals 49. But the answer can't be 49. The longest side is 25, so it can't be 49. That's what x squared is. The inverse of squaring something is the square root. So I need to take the square root of 49, which is 7. That makes sense because the longest side is 25. That looks to be quite a bit shorter than these ones, so it could be 7. The diagram's not to scale, but it's still worth checking. Does the answer seem reasonable? It must be less than 25. So 7 is fine. Number 6, we always start by putting the numbers into ascending order. The mean, I've added all these numbers together, which is 46.4. I need to share that out equally between the 7 numbers that we've got. So that divided by 7 is 6.63. And again, does that seem reasonable? Well, the numbers go from sort of 5.8 to 7.4, roughly 6.6 in the middle, which is the median we'll come to in a minute. So having a mean of 6.63 seems pretty good. It seems to be around what we've got in this data. The mode, well, there's no most common number there. That every single number is different, so there is no mode. Please don't put 0 for that. That would lose you the mark. 0 is a number. The mode is not 0. The mode the answer is there's no mode at all. So make sure you've written down the words no mode, please. For the median, they're already in order. I want to find the middle one. So I could cross out the smallest and the biggest, smallest and biggest, smallest and biggest, and we're left with the middle one. You can see there's 3 that side, 3 this side, and 1 clearly in the middle. So 6.6 is the median. And finally, the range is the difference from the smallest value to the largest value. So 7.4, subtract 5.8, the difference, that is 1.6. Number 7, I can do by saying 178 take away 86 gives me 92. If I look across then, the female children and the female adults must add up to 92. So 92 take away the 43 adults leaves me with 49 children. I could then look down and say, well, 52 male children, 49 female children, add those together to get 101 total children. And then finish those gaps. Going across, we've got 101 children plus something adults equals the total. So again, 178 minus 101 will give me 77. The pie chart, the key bit is the angle calculation. There should be a third column here which has got the angles in them. To do that, we first need to work out the total frequency. In this question, there are 720 pieces of data. Now, I want to show that data in this pie chart. Around this point, the angle will add up to 360 degrees. So we have to ask ourselves, how many times can we fit this data into 360? Well, let's do a division. Let's do 360 divided by 720. In this case, that's a half. That is a half as big as 720. So if I half all these numbers or times them by 0.5, that will give me the angles. Now you should check, do these 4 numbers add up to 360? Because they should do. That means they'll all fit perfectly in a pie chart. So always check, do your angles add up to 360? Then we can try and draw them on the diagram. Now, 205 could be a difficult one to start with. So I've started actually with 60 here. I've drawn that the first section here. Then I've moved my protractor around in the 70 for fruit juice. Then 25 for water, which leaves me with the 205 degree last. Make sure you've labelled in the sections what the drinks are. Don't put the angles, please. Make sure you've written down the topic or the category. Tea was the big one. Coffee, fruit, juice and water. Make sure you put the letters or the words which describes that category. The key thing is you've shown the working out for the angles. You must have the angle column in there by finding the frequency and dividing that into 360. For number 9, look at the scale. There are 5 small squares from 0 to 100. So 100 divided by 5 is 20. That means it goes up in 20s. So Monday is 20, 40, 60, 80. Tuesday's 100. Wednesday and Friday the same, and that is 1 square below 200. So 200 take away 20 is 180. And Thursday is 2 squares above 300, so 320, 340. The key thing is to work out your scale really carefully. So part A, the 2 days is Wednesday and Friday the same, 180 on both those 2 days. And part B, I've added together 80, 100, 180, 340 and 180 again to get 880. Don't assume it's going up in 1s or 10s. Look at the scale carefully. That's the first thing you need to do. Number 10, usually we've got the table drawn for us, but this time it has to draw us ourselves. So what I've done is I've said for the first spinner we've got 3 outcomes. It's either going to be a 2, a 5 or an 8. And for spinner 2 we've got 3 outcomes as well, a 3, a 4 or a 7. Now it says he spins the spinners and adds the scores together. So by putting addition up here I can see them adding all these scores together. 2 plus 3, 2 plus 4 and 2 plus 7. 5 on spinner 1 with either 3, 4 or 7. So 5 plus 3, 5 plus 4, 5 plus 7. And so on. It could ask you, what is the probability that the score is an odd number? Well, look at our diagram. There are 9 outcomes there. 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. There are 1, 2, 3, 4, 5 odds, so the probability will be 5 out of 9. So this diagram will help us to answer questions about probability. Question 11, we need to read it really carefully because 0.12 is the probability or the relative frequency of being late. So 0.12 times 75, that tells us that there are 9 buses that are late. But the question asks for how many times was it on time. So if 75 in total and 9 of them were late, if I take that away, that means the rest of them were on time. So please don't just do 0.12 times 75 because we're used to it. Make sure we read the question. Does it want the ones that are late or does it want the ones that are on time? Take that away to get the difference. We've got our final answer.